You need one.
Yeah, I think that's why you would be where I am with my workout. There's no way. There's way. There's way. Except I'm at a table, so like if I sit like this,
All right. Great. Okay, so today what we're gonna do is, Ms. Jerkstuff yesterday did 2 problems on volume. And one was a prism and one was a pyramid. Today we're gonna work more on volume, and then we're gonna get into some things on translations, reflections, rotations. So first of all, the generic, yep. Okay. Was anyone else gone yesterday that needs the packet? So anyway, the generic formula for volume of any 3-dimensional figure, they use capital B to stand for area of the base, okay? And if you look at what formulas you are given when it comes to your formulas here, they don't give you the formulas for volume of a sphere, volume of anything. So when you guys get close to taking your MCAs, I strongly suggest that you look over these. I would keep these note sheets and I would look over the volume formulas before you take it, okay? First of all, for a prism, it's volume equals capital B, which is area of the base, and we would never have to do one that's not a rectangular prism, because you guys at this point do not know how to find the area of a pentagon, so they'd never give you that one. What they would give you is a rectangular prism, and when you do this one, the easiest way, I would almost guarantee this would be on your test. The easiest way for this is to just go length times width times height when you're doing volume of a prism, okay? Then if I look, I have a cylinder, and here's the deal. If something is either a rectangular prism or it's a cylinder, your volume is gonna be capital B times H, which means area of the base times H. This area of the base right here would be the area of the circle, or this circle, whichever way you think about it. And what you would have to realize there is the area of a circle is pi r squared. So that's how they got this formula. So I'm hoping on the test you could at least remember volume equals area of your base times the height. And then if it has a circle, the area of a circle is pi r squared, so that goes in for that capital B. When we have a pyramid, the only way that a pyramid is different than a prism is it has the 1/3 in front. The reason it has that 1/3 in front is a prism doesn't just go up, you know, on all sides. It goes to the middle, so it loses all that volume on the sides. So again, if you could remember that it's 1/3 base times area of the base times height, another way you can do this is you can go 1/3 length times width times height. So a pyramid would be 1/3 length times width times height. Now a cone is similar to a cylinder, excepting again, it's the 1/3 because it's going up to a point and it's missing all that volume around it. So it has the same formula as the cylinder, except there's 1/3 in front of it. Again, area of your base, that would be a circle, which is the pi r squared. So it's 1/3 pi r squared is the area of your circle times the height. And then I believe this one is on your MCA test too from last year, and you would have to remember this formula. So it's 4/3 times pi times r cubed. And I don't know if they actually have you like evaluate it and give you a calculator, or if they just, you'll see some of the questions, you don't actually have to find the actual answer, you'll see that. But I believe there is one like that. These are the same thing, the only thing that's different is like rectangular prisms, I would just do length times width times height. Same with a prism. If I had the height of a prism, or pyramid, sorry, if this was my height, this was my length, this was my width, I would think of this as 1/3 length times width times height, okay? For the cylinder, again, it's capital B, which is pi r squared times height. Cylinder and cone are the same, except the cone has that 1/3. And then again, like I said, sphere you could see, and you would have to know that formula. So I already showed you this. These are the formulas you get on the test, and there's nothing here for volume, but there's a lot of questions on volume. So this one here is a cone. So I would think that day you guys could remember 1/3 capital B times height, and that capital B would be the area of this circle, and an area of a circle is going to be the pi r squared. So that's how they could replace the B with pi r squared, okay? Now, what we're gonna do is use that formula, and we're just gonna substitute in. So I'm gonna go 1/3 pi, my radius squared, the radius they give us, so it's just 4.5. One thing I notice about the test, when I do 4.5 squared, I would put it in parentheses and put the 2 outside, but they do it inside like this. It's the same thing, doesn't matter, but I just wanted to point out they put it inside. And then the height would be this perpendicular height, which would be 14.25, okay? So what we need to do is just figure out which one this is. Another thing too, for pi, they don't use the pi key, they use 3.14, which in our class, we've been using our pi key on our calculator. So it'd be 1/3 times 3.14 times, it's not this one because there's no 1/3. This is 4.5 cubed, so it's not that. This one took the radius and multiplied it by 2 and got the diameter, and we don't want that. So it's gonna be this one right here, okay? So like I said, sometimes you just put in stuff, but they will not give you the formula, okay? So here we have a cylinder, and again, volume for a cylinder or a prism is capital B times H. Capital B is area of the base. In a cylinder, your base is a circle, and the area of a circle is pi r squared, okay? So what we're gonna do here, we have pi, which I'm gonna put as 3.14. The r, if your diameter is 10, your radius is 5, and that's squared. And then your height is the 36, okay? Now, here's what they did. Now notice here, they put times the area of the base, okay? So I actually should have, they did not break it down into pi r squared h. What they did instead, so I'm gonna get rid of this. What they did again instead is they used this formula right here. So I'm gonna go volume equals, and you would go the area of your base multiply 78. Oh, I see what they did. They found the area of the circle first separately. Okay, so they found this first. Sorry about that. And the area of your circle is pi r squared. Like why they did it in parts like that, I'm not sure, but that's what they did. So when I do this one, I'd go 3.14. My radius is 5, and they would put the squared inside, just so you know. So now what you could do there is multiply that and see what you get. And I'm guessing on this one, guys, you would either multiply it kind of and get your best guess what it is, like estimate it if you did it by hand, or a calculator would come up. And we could go 3.14 times 5 squared, which is 78.5. Okay? So that ends up being, I'm going to change this to capital B because that's what they use for the area of your base. And then what they want us to do is take capital B times H, and our capital B is the 78.5, and our height is 36. So 78.5 is what we got for the area of the base, and our height was 36. And that's as much as we had to do with this one. So multiply 78.5, which is the area of the base, by 36, which is the height of the cylinder. Okay? So that one would be our answer. Now, if we look at this one, if you notice, they're giving us the diameter again. The diameter is 17. Our radius is 17 divided by 2, which would be 17 divided by 2 would be 8.5. Okay? Now, again, you'd have to remember that formula, 4/3 pi r cubed. So if we have 4/3 pi r cubed, we would go 4/3. Pi, they just left over there in our answers, so I'm gonna leave it. And then it would be my radius here, 8.5 cubed. Okay, so I just have to find which one is that, which is this one right here. Okay, so that's where I was saying, like, sometimes they just have you do a part of the problem and not actually come up with the answer. This says that we have a circular cylinder and we can't use a calculator. So I'm gonna first draw a cylinder. Okay. And what they tell me for this cylinder is the diameter is 6 meters and the height is 12. Okay. When you do volume of a cylinder or volume of a prism, that's when it's capital B, which is area of your base times your height. Okay. It's when you do the cone or the pyramid that you have the 1/3 or 1/3 in there. All right, so I'm gonna write down my formula, and because it's a cylinder, your area of your base is pi r squared. So I'm gonna go pi r squared h. And now notice in this one, they want us to leave the pi just as pi. So what I'm gonna do is I would have pi my radius, if the diameter is 6, our radius would be half of that, which is 3, and our height is 12. Now again, you can't use your calculator on this. So what you would want to do is just think 3 squared is 9. So this is really 9 times 12. And then you would either have to do 12 times 9 in your head, or if you can't do that, what you would do is just long multiplication. So you'd go 12 times 9, 2 times 9 is 18, you'd carry the 1. 9 times 1 is 9, plus 1 is 10, so it's 108 when you multiply these together, and then you still have the pi. So this is your answer. Okay. This one we can use a calculator in, and we have a cylinder again. So if I draw my cylinder, if you're somebody that doesn't need to draw it out, you don't have to. And in this one, they tell us what our volume is. It's 8792. They tell us our height is 7. And which of the following represents the radius of the cylinder? So this is different because we don't know what the radius is, but we have to find what the radius is. Okay? So here is what we have. We have volume is pi r squared h. Okay? Our volume is 8792. Our radius is what we're looking for. So I'm going to keep that as r squared, and our height is 7. Okay? Now this is one we can use a calculator with. So here is what I would suggest when you guys go to solve this. I would multiply pi times 7 on the right side first. Okay, so I would go and I would type pi times 7. And we can round that to 21.99. Okay. That was our pi times 7, and then we have r squared. Okay. Now what I would do is divide by 21.99. And when I do that, I would get, I'm opening the wrong thing. When I do 8792 divided by 21.99, I get 399.82. And what do I have to do then if that's r squared? Square root. So now, what I would do is take the square root of what we have, which we could just go second square root, second answer. And doesn't that round up to 20 really? 19.995. And 20 is one of our answers. So that would be our answer is 20. Okay. All right, when we look at this one, again, we have a cylinder. And remember, the formula for either the prisms or the cylinders are capital B times H. So we have this cylinder, measurements are shown at the right. If 3/4 of the space inside the container is filled with sugar, how many cubic inches of sugar are in the container? Don't let me forget to answer that. Okay, so we first have to find the volume, and then what we're gonna do is take 3/4 of that volume. Okay, again, we have a cylinder, so we can use the pi r squared h. So let's start with that. So volume is pi r squared h, and we can use a calculator. So we're gonna go pi, our radius is 4 squared, and our height is 12. Okay, so what I'm gonna do then is I'm gonna open up my calculator, and I would go pi, so I'm gonna go second up arrow, which is pi, times 4 squared times 12, and that is 603.19. Is that what you guys got too? 603.19. Now, if that was all you were doing and you were a little bit off from that answer, like say all we had to do was find the volume, I'm guessing what they did there is they used 3.14 instead of pi. So if I went 3.14 times 4 squared times 12, notice that is going to be a little bit different, okay? Regardless, now what we have to do is take and figure out if that's the whole volume and the sugar is 3/4 of the space, how much volume of sugar is in the container. So for our sugar, we would just take 3/4, which is 0.75, times 603.19. So again, I can use a calculator on that. And we had gotten this answer up here, so I'm gonna use that one, 603.19. But again, if you're ever a little bit off, it's probably just you use pi and they use 3.14 or vice versa. So this would be 452.39. Okay, and if you look here, we have something very close to this, and it's probably because they used the 3.14 instead of the pi. Okay? All right. Now, if we go to this page, again, we have a cone, and it has a volume of 4,710 inches. If the height of the cone is 20, find the radius of the cone. Okay, so we have this cone, and in that cone, the volume is 4710, and what we do know about this is that the height is 20, okay? So the volume is 4,710. So I'm gonna write down the volume of a cone. The cone goes in, so that one is 1/3 times the area of the base times the height. So it's 1/3 area of the base times the height. Now, area of the base is going to be my pi r squared. H. So I go 1/3 times pi. The radius is what I'm looking for here. So I'm gonna just put r squared, and my height is 20. And I know my volume over here to be 4,710. Now, here is what I would do on this one. On the left side, you have 3 things you can multiply. You can go 1/3 times pi times 20. Now, like we talked about with fractions yesterday, fractions, if you do 0.3 for 1/3, and somebody else does 0.33, and somebody else types in 1/3, you can get a big varying answer for that. So if that's 1/3, I would use parentheses 1 divided by 3 parentheses. Or you could use the fraction key that Ms. Jerpseth showed you if you have a CE version. Now I'm gonna also multiply my pi, and I'm gonna multiply my height, which is 20. And then I'm gonna rewrite it here, and I have 4710 equals, I multiplied the 1/3, the pi, and the 20, and I got 20.94. Okay, r squared. And then what I'm gonna do is solve that. So I divide by 20.94. And my r squared equals, so if I take 4710 divided by 20.94, I get 224.93. Do I have something that I have to do still? I have to do the square root, right? So now what I would do is take the square root of 224.93. And if I do that, I can go second square root. I could take it of that whole thing. It's just whichever way I do it, I might get a little bit different answer. I put in the 224.93, and wouldn't this round, if I'm doing it to two places, what would it round to? 15. 14.997 is going to get me 15, and that is in inches. So my radius is 15 inches. Now I was telling you guys that when you do this, you do less than 20 questions in a class time. So if I was doing this one and I had my radius that I solved for, couldn't you use your formula and check it to see if it equals 4710? So that would be a way that you knew it was correct. So you could go, okay, my volume is 1/3 pi r squared h, and I just found my radius to be 15 squared, and my height is 20. So I could go to my calculator, because this one I can use a calculator on, and I could go parentheses 1 divided by 3, parentheses, times pi or 3.14, and then 15 squared times 20. And what you would want to be close to is that 4710. The reason it's not exactly 47.10 is because of rounding, but that's close, okay? And maybe if I did that same thing and I just went in where it was pi and changed that to 3, and then I'd have to insert a spot, 1, insert a spot, 4, and then I probably should have just deleted this, but anyway, let's clear that and let me try doing the whole thing. 1/3 times 3.14 times 15 squared times 20, and that is 4710. So they used for this problem 3.14 rather than pi, okay? All right, if we look down here, I'm just gonna talk about this for a little bit. The last thing that we talk about in this chapter is translations, reflections, rotations, and dilations that we just did, okay? Remember that a translation was just like a slide. It's like you take a figure and you slide it up and to the right or down and to the right, left or right, up and down. You don't turn it, you don't flip it. A reflection, usually they do it over the y-axis or the x-axis. This one they did over the y-axis. So it'd be like if I could fold this in half, those smiley faces would fold right onto each other. This one you might first think is a reflection over the Y, but notice that they're not the same, and they would have to be. So this one was actually rotated about the origin. So it was rotated probably at a 90-degree angle at the origin, and that's how they got that new figure. And then dilations we just talked about, okay? So we'll talk about this more on Monday, but one thing we talked about just the other day, when you do reflections, rotations, dilations, the first figure is always normal ABC. The new one is A prime, B prime, C prime. That's a reflection. This one was rotated about the origin again, and you can tell that because it's actually turned. Translation is just shifting it left and right, and a dilation. This one they started with the blue and they ended with the red. So their scale factor, would it have been bigger than 1 or less than 1? Less than 1, right? All right. And then I talked about this the other day too. When you dilate two figures, they are going to be similar figures. Their corresponding angles are the same. Their sides are proportionate. And we talked about if k is less than 1, it's reduced. Equal to 1 is congruent, and greater than 1 is enlarged. So you guys have that homework sheet that you've been working on, and I will let you know which ones you can do. So you're gonna do 10 through 16. All right, 10 through 16. Now, sorry. Now again, do you guys mind just keeping the notes and worksheet for Monday, and we'll finish both on Monday? And when you turn in the homework from Monday, you're gonna get 30 points on it because it took us 3 days, okay? So we'll write 30 points on it on Monday.